Hello friends, welcome to the presentation on successive differentiation. I am Dr.Rajeshree. In the last presentation, we have seen the nth derivatives of some standard function. In this presentation, we'll revise the same and we'll continue with the examples based on the nth derivatives of standard functions. We'll start with the function. If y is equals to x raised to m, then yn is m into m minus 1 up to m minus n plus 1 into x raised to m minus n, and ym, which is equals to m factorial, and yn is 0 if n is strictly greater than m. Next function is ax plus b raised to m, then yn is m factorial upon m minus n factorial a raised to n into ax plus b raised to m minus n, and ym is equals to m factorial into a raised to m, and yn is 0 if n is strictly greater than m. Next is y is equals to 1 upon x plus b, that is equals to x plus b raised to minus 1, then yn is equals to minus 1 raised to n factorial a raised to n upon x plus b raised to n plus 1. Next function is y is log of ax plus b, then yn is minus 1 raised to n minus 1 minus 1 factorial a raised to n upon x plus b raised to n. Then the next function is y is equals to a raised to mx, then yn is m raised to n a raised to mx log a raised to n. Next function is e raised to mx, then yn is m raised to n e raised to mx. Next function is sin ax plus b, then yn is a raised to n sin ax plus b plus n pi by 2. Similarly, cos ax plus b, then yn is a raised to n cos ax plus b plus n pi by 2. Next is e raised to ax sin bx plus c, then yn is r raised to n e raised to ax sin bx plus c plus n theta, with r is equals to under root a square plus b square, and theta is tan inverse b upon a. Similarly, for e raised to ax cos bx plus c, yn is r raised to n e raised to x cos bx plus c plus n theta, with r is under root a square plus b square, and theta is tan inverse b upon a. Now we'll start with the solved examples. We'll see here example. If y is equals to log 3x plus 5, then find yn. So here rule is if y is equals to log ax plus b, then yn is minus 1 raised to n minus 1 minus 1 factorial a raised to n upon ax plus b raised to n. So here comparing the function with log ax plus b, our a is 3 and b is 5. So just we have to replace a by 3 and b by 5 in the same yn formula. So our yn becomes minus 1 raised to n minus 1 minus 1 factorial 3 raised to n upon 3x plus 5 raised to n. So it's a simple solution. Next example is find the nth derivative of y is equals to 1 upon x square minus 5x plus 6. So consider the function y is equals to 1 upon x square minus 5x plus 6, and we know that we can factorize it. It is a quadratic equation, so we can factorize it into x minus 2, x minus 3. So it becomes 1 upon x minus 2 into x minus 3. Here we have to use the partial fraction. You all know the method of partial fraction. You have to rewrite it is equals to a upon x minus 2 plus b upon x minus 3. Then alternatively you have to substitute x equal to 3, x equal to 2, and you will get a and b value. So here I have done the calculation. I have got a as minus 1 and b as 1. So here is the solution by using partial fraction. But still this is not the final answer. We have to use the formulas of nth derivatives and we have to get the answer. So consider here the rule. By rule, if y is equals to 1 upon ax plus b, that is ax plus b raised to minus 1, then yn is minus 1 raised to n factorial a raised to n upon ax plus b raised to n plus 1. So here is the solution. Here we have two factors, that is minus 1 upon x minus 2 and 1 upon x minus 3. So here first term is for first term, minus 1 upon x minus 2. We have the yn minus 1 raised to n plus 1, because there is minus 1 sign already present, and into the formula minus 1 raised to n. So here the first term is minus 1 raised to n plus 1 into n factorial upon x minus 2 raised to n plus 1, and the second term directly by using the formula. It is minus 1 plus minus 1 raised to n factorial x minus 3 raised to n plus 1. And here is the solution. Next is, if y is equals to e raised to x sine x plus 3, then find yn. Y is equals to e raised to x sine x plus 3. Comparing with y is equals to e raised to x sine bx plus c. See here e raised to x, so coefficient is 1, so a is 1, bx plus c, so b is 1 again, and c is 3. So we have got the values of a, b and c here. Now we can find r. R is under root a square plus b square. So it is equals to under root 1 plus 1. So it is root 2. And phi or theta, you can take the symbol. It is tan inverse b upon a. So it is tan inverse 1 upon 1. So it is pi by 4. Then yn is equals to r raised to n e raised to x sine bx plus c plus n phi. So it is r raised to n is root 2. So root 2 raised to n e raised to x sine x plus 3 plus n pi by 4, and here it is the solution. We can rewrite it as 2 raised to n upon 2 e raised to x sine x plus 3 plus n pi by 4. Next example is, if y is equals to e raised to 3x cos 4x plus 5, then find yn. So here again the same method, comparing with the y e raised to ax sine bx plus c. We have a is 3, b is 4 and c is 5. So r is under root a square plus b square, so it is equals to 9 plus 16, so it is root 25, so it becomes 5. Theta is tan inverse 4 upon 3, and yn becomes r raised to n e raised to x cos bx plus c plus n theta, so it is 5 raised to n e raised to 3x cos 4x plus 5 plus tan inverse of 4 by 3.